All right, so I'm Lee Branstetter. It's my pleasure to chair our first session. If I could ask Ina to come on up. We're starting out a little ahead of schedule. We want to stay on schedule, so I need to apologize to the speakers and discussants and all of you in advance. In keeping with the predilections of my Teutonic forebears, I'm going to try to be very strict on the time limits that we've set. So again, 20 minutes for speakers, 10 minutes for discussants, and then 10 minutes for Q&A, and then we're going to go immediately to the next presentation. So we're delighted to have leading us off in the first session, Ina Ganguli. She is going to be presenting a paper entitled Price Shocks in Scientific Production, Evidence from University Procurement Contracts, co-authored with Raviv Murciano-Goroff. The discussant will be Karim Lakhani. Ina, please take us off.
Thank you. As Lee said, this is co-authored work with Raviv Murciano-Goroff, and this is work in progress, but it's part of a larger research agenda that we're working on, and we're really grateful to have the chance, for me to present this, because I really think this agenda is really kind of speaks to, what Zvi Griliches, his legacy and things that he was talking about. I will say I was a graduate student in Cambridge, part of the innovation community, and benefited a lot, from a lot of people in this room who were teaching me and talking to me. I definitely heard Zvi's voice through the people that, I got to interact with. Just yesterday, Lee and I were talking about Lee's experience being his student. Part of what I really loved about having that chance to present here is that it gave me a chance to go back and read more of Zvi's work, other than kind of the classics that we cover in our innovation courses, and particularly some things that he was writing, later on where he was reflecting. And I found this quote that I really think kind of speaks to what Raviv and I are trying to do, which is, speaks to his legacy of economic measurement, where he wrote, this was it was published in 2001, so it was already, later, but he wrote, the most difficult measurement area concerns the production and dissemination of information and new knowledge. How are we to measure and evaluate our investments in science and in economics itself? Almost all of the production of science escapes our current measurement techniques. Yet, that is where the future answers to our old questions are likely to come from. And in this piece where he wrote about this, he also talked about how graduate students should be trained to think about collecting these data, finding new data, and to think about measurement. And so this project is really getting at this, and I think for this session, those of us who are thinking about this question of getting into the black box of scientific production, we know that scientific productivity depends a lot on these inputs, material, labor, and the prices are often fluctuating, but in our usual data sources, and the data sources that were available when Zvi was working, you can't observe the inputs, right, or their prices. And so these are just a few examples of things that have been in the media, right, about inputs that scientists use are important for their work, but that might suddenly have a price shock. And so for example, like plastic. During COVID, we saw there were a lot of shortages, and so scientists were, not able to have their pipettes. I'm going to, talk about some of the other pieces of our research agenda, but one of them is also thinking about changes in the cost of labor, and so grad unions and unionization, which has gotten a lot of attention. And so what we're going to, do in kind of a larger work, and then, start to do in this piece, is that, try to look at if we, can actually observe then these price changes on particular inputs. How does that really affect then the rate and direction of science, and who's doing it? This is, I'm going to talk today about helium prices. So if you don't know much about helium, you'll know a little bit more today and about how it's used in science. And then we have some other work on minimum wages, actually. And if those of you who are on Twitter or X might remember when there was a big controversy when an economist said, if I'm required to pay undergrads $15 an hour, I will hire fewer of them. And that actually was very controversial and led to a lot of discussion. And so we kind of try to explore some of these things in this work. Okay, and so when those of us who are working in this area of getting into the black box of scientific production, we know that it's difficult, right? The causal questions, it's hard to actually estimate the causal impact of price changes on science, and I talked about the microdata, so that's one of the challenges. So you need to get prices, input prices that labs face. Ideally, you'd want to actually observe their use of inputs. And then, the bread and butter of our field, right, is also then scientific outcomes. So that's where I think we know a lot about kind of how to measure now, papers, topics, and we'll be hearing a lot about that today. One area where we're going to go into, hopefully, in the next steps for this paper is trying to kind of really get at, from papers, if you can extract data on how many experiments scientists are doing and getting at, kind of those decisions that scientists are making. Okay, so what is this paper about? So we're going to look at how scientists respond to increases in the price of specialty research gas, in particular helium. And we're going to look at how scientists are adjusting their use of helium and then other inputs as well in response to these increased prices. And we're kind of thinking through what are the different potential ways that scientists can respond. And for today, what we're going to show you is really just looking kind of at papers and the use of inputs. And the reduced, if the price increases, then they would reduce probably their use of helium. But how does it affect the rate and direction of research? Well, if one outcome is that there could be fewer papers that they produce, right? They're going to kind of scale back, same quality. There could be the same number of papers, but the quality declines. And this is what I was saying. We want to try to get at actually, can we observe how many experiments scientists are doing? So I don't know if I'll have a chance to get into it, but one field where this is very important is low temperature physics. And when we've talked to scientists, they've said, well, yeah, if we have less helium, we can't actually do as many measurements, and then we'll have fewer kind of data points in our graphs. And so those are the kind of things that even to get even more micro, we're hoping to get at data like that. And then, there can also then be a change in the direction of research, right? So they could actually change what experiments they're doing. Maybe they'll actually move more to theory, right? And so there, the number of papers and quality is uncertain. Okay, so I mentioned this already, but just to, tell you, again, what we're kind of doing more broadly. So we have, this work in progress. We also have a paper on minimum wage changes where we show that undergrad RAs, there's response in their employment to minimum wage changes in the U.S. And there, we're interested in seeing then, how can universities respond? And I will say in this, larger literature, we know a lot about how firms respond, right, to price changes, but we don't know a lot about university researchers where a lot of research is done. The other thing that's in progress is we're collecting grad union contracts, and so we have kind of a large set already, and from that we're extracting things like minimum stipend levels, but other things like benefits, health care, other things like that. Okay, so let me get to the setting. So helium production, if you haven't followed it, you might have seen that, the price of your, helium balloons have gone up when you go to, have a birthday party. But this is something that's really affected scientists. And, so 75% of the world's helium comes from Qatar, ExxonMobil in Wyoming, in the U.S., and there have been basically a lot of changes that have led to this just production, where you can see fluctuations in the amount, the world production of helium. And as I said, in some fields, helium is very important, and so cryogenics, MRI, NMR, which is what we're going to talk about today, especially, and then physics research, like I mentioned. And so why is it really useful? Well, it enables extremely low temperatures, so they can, again, do these experiments at low temperatures. And, I think for our purposes, it's an interesting input to look at because there's no replacement for it. And, so the societies like, American Physical Society and others, ACS, they've really been writing a lot about this and kind of, this is an important thing for scientists in these fields. Okay, so the price is volatile, and I'll show you a graph of the price. And there have been rapid changes for a variety of exogenous reasons. So as I said, there's, you can see here, there's a lot of changes in the world production. And, if you get into some of these things, they're, very interesting about kind of the Qatar-Saudi Arabia diplomatic dispute that affected them, how much helium was accessible to the U.S., privatization of the national helium supply, and then demand shocks actually then play a large role. But for our purposes, science is actually a small share of the demand. There's larger, kind of demand shocks from actually manufacturing and these other kind of industry demand. The other thing that's important is that it's not easily stored, so there can't be stockpiling. It burns off, it leaks. And then for those IO economists, it's a pure commodity, and so prices are not going to reflect quality differences. So it's really kind of the price is kind of going to change just because due to these other factors. Okay, so this is just kind of to give you some descriptive evidence on what has been going on. So this is the price, world price of helium, and it's relative to 2000. That's the blue line, and the red are articles that are using helium in PubMed. And so what you can see is, it looks like something's going on, right? So you have, around 2010, as the price really kind of, starts to increase relative to 2000, you see a decline in helium articles. It's about, like a 10% increase in price is about a 7.5% decrease in articles. Now, this, again, going back to kind of the data that maybe Zvi would have been looking at, this is aggregate, data here. And to really understand what's going on, we would want to, be able to observe, actually, what are the actual inputs that scientists are using. And, we can see here that, you see this correlation, but it could be that everyone's moving away from helium. And it doesn't really help us see, like, what are the decisions that scientists are making. And so what we're going to do is go to this more detailed micro-level data. Okay, so I think one of our contributions here is that we're going to be using data from these university procurement contracts. And, as I showed you earlier, the price of many materials used by laboratories fluctuate a lot. And because of this volatility in prices, universities often write these contracts with suppliers to fix prices for a given period of time. And then, when there's an expiration, right, or renewal, they're going to renegotiate the price. So our approach is we're going to use variation in the timing and also the magnitude of the prices in these procurement contracts across universities. And I'm not going to really show you today event studies, but we can also then do these event studies around the price changes. And so what that is going to look like, this is actually I'll show you more, but this just shows two universities in our data set where this is prices for UHP is ultra high purity helium in T tanks, and so we know the purity level, we know how much it is, how it's stored, and what you can see are these are two U.S. universities that have different prices. There's changes right at different times, and so it's kind of a nice setup where we can again look at scientists who are in the same field, but they're going to face different prices. Okay, so the data, how did we get it? So we we did FOIAs where we requested contracts regarding lab gases. We have them from 16 universities right now, but we can actually expand the sample. It's mainly public universities because they're the ones that we can FOIA, and we can actually parse the prices for different gases. So right now we're only using helium, but there's a lot of information there, we can maybe, when we get into the discussion, get into some of these other things that I've mentioned about why we think this is a good source of data. This is just one example then of what it'll look like. So it shows the material, the description, we'll show the price. And again, there's kind of a lot of information in these contracts. So this is the current data. So you can see that, again, there's a lot of variation. There's even, this one university where there was, a drop in the price, and Raviv actually, called that university and got the story, and they confirmed that was correct. And it's some of this happens because of kind of, mistakes in some ways. Not mistakes, like that's the actual price they face, but there's a lot going on, and sometimes when they're renegotiated, they'll negotiate these prices. Okay, so I don't think I have time for getting into the challenges here, but if it's of interest. Okay, so what are we going to link it to? So we have the contracts, and then many of you are probably familiar with the U-metrics data, which is essentially, from a number of universities, data on, transaction level data on spending at vendors. It's, we really can only observe this for sponsored research. So this is, PIs who got grants at their universities. But what's nice about it is that we can actually observe the employment of lab members paid on each grant. And what we're going to do for now then is we're going to, we actually can't observe the quantity that's purchased. So we're going to back out the helium quantity from deflating gas spending by the contract price. Okay, so our publications are going to come from this kind of crosswalk between U-Metrics and PubMed Central papers. So right now we're using PubMed Central, which again is kind of doesn't actually give us all the papers that we're going to be interested in, but that's what we have for now. And what's nice about PubMed Central is it actually has flags for helium and then the other areas that would use a lot of helium. So NMR, MRI, et cetera. And then we'll also have forward citations. Okay, so our sample is we have federal grants, 16 major universities. Right now it goes through 2019. Some other sample restrictions, you have to have one employee charge the grant, and you have to have purchased from a specialty gas supplier. Okay, so some summary statistics as of now. So we have, we have about 50,000 observations. This is lab quarter level, though. It's about 3,000 labs that we have in the data set. And you can see, we have days, so it's actually like the days that are charged for different labor, and then spending, et cetera. Okay, so for now, so again, we're moving towards an event study framework, but for today I'm going to show you just estimates from a two-way fixed effect model. And so essentially, what I'm going to show you is, why is our outcome of interest, so papers or the quantity of gas. It's going to be the lab level. We have, university fixed effects. And then we're going to, the variation that we're going to use is really in the price of gas. So we have the log price of gas. Okay, so as I said, this is in progress. So we have, some results to show you. The first one is actually just from an event study that we ran with, using the quantity of gas. And so this is when we had the price change, and then what happens to the use of gas. And so where we're going to head next to is thinking about intensity of helium usage and who is it that's responding. And so here, though, we're using whether it's a large increase in the gas price or not. And so you can see, it's noisy. We're adding more data from more contracts, so that should help a little bit with the precision. But you can see that for the larger increases, there's kind of a larger decline in the quantity of gas purchased. And so this is the kind of thing where it's like a first stage, in some sense, right? You just want to know, do they actually change their use of gas, which we kind of assume, but to kind of see it is one thing that we wanted to do. And then this is in the two-way fixed effects, model. And so we have quantity of gas and then quantity of other, which is basically non-gas research material inputs. And so this is where we're starting to see some interesting things, that the quantity of gas goes down, but the quantity of these other inputs actually increases slightly, which is suggesting that maybe they are substituting towards something else, okay? So, and this is where getting into the text of papers will help us uncover what that is, but right now it looks like there is some substitution there. For labor, and this is where we weren't really sure what to expect. So if labor is it's complement, right, to using helium for these experiments, we would see a decline in the use of labor. And what we've also heard from scientists we've talked to is they said sometimes the costs can get so high that they actually can't fund a grad student for a summer, for example. So then you might see a response here, and so that's what we're seeing, some kind of slight decreases in actually all types of labor, which is suggesting, again, that it is also affecting these inputs. Okay, so for a number of papers, the first one is just a linear probability model with, any article or not, and we actually don't see anything there. And then we have the number of articles, and this is a Poisson, and it's, again, we see this small decline, so like a 10% increase in the, or 1% increase in the price is about a, 1.5, I think, okay, decrease in articles, percent. And we don't see much on quality there yet, but again, I think we can probe into this more. And then where we're really trying to focus energy next is on the type of paper. So it does look like they're substituting to kind of other things, and we can see in the articles that they're doing kind of fewer NMR articles, fewer MRI articles, and so that suggests that we overall see a decline in publications, but the decline actually for the these papers, it's it's smaller, and it looks like maybe then they're kind of shifting into other papers. Okay, so I won't go over, over everything that I just said, but I think the takeaways are that it looks like scientists are responding. We have this very micro data where we can observe input use and prices, and it does look like there's a decrease in the overall production of papers, and they're using fewer helium papers. So it's really suggesting this slowdown in the rate, but also the direction of science. And so, policy implications, these are not firms, this is a university, and they're funded by NSF, NIH. And so, if this is mattering a lot, it's a question, should there be insurance mechanisms or increased budget flexibility among universities or funders of research? And like I said, what we really am eager to, get feedback and ideas is, which topics are PIs moving into? Is there heterogeneity by field? Another thing is that universities can invest actually in fixed capital. So there are these helium recyclers that cost a lot of money. Very few of them out there, but is that something that is happening too? So I will stop there because I think I went over slightly.
Thank you very much.
Thank you.
Good morning, everybody. Great to see everybody, old friends and new folks as well. Want to walk through Ina's paper and Review's paper and give you my perspective on it. Fonts are looking super weird. Okay, we'll figure it out. Okay. First of all, I think that this paper is asking a really important first-order question in our literature, in the economics of innovation and science literature. Which is how do variation in input prices for scientific production impact knowledge outcomes? So I think this is surprisingly, it's understudied. That people have not had a chance to go after this. Some of that has been because the data has not been available, and the work out of Michigan to set up this large consortium of universities and get grant level data is pretty remarkable. And it's great to see Ina and Raviv take advantage of that. Now, the thing that's interesting, and what I learned, once you think it through, it makes a lot of sense. Price shocks by scientists can't be passed on to customers. There are no customers, right? The customers are ourselves as producers. And grant agencies certainly don't allow for input price adjustment. And universities may be slow to adjust to inflationary pressures on inputs as well. So it is a bit interesting, and especially the data set ends at 2019, but we had this massive inflationary period starting in 2020 and on. I'm sure that this is potentially providing us with some underestimates of what may be going on. But also just overall, it's sort of important to understand the full accounting of the knowledge production function. Some of the work that Kyle Myers is also doing is sort of trying to get at that as well. So it's great to sort of see advancement in this space. And it's cut off. May have impact on the rate and direction of research. Okay, something like that. Yeah, something. You know what we're talking about. So the paper in a nutshell. Okay, again, investigates the exogenous price changes in helium. U-metrics data from Michigan, 3,000 labs, 16 universities. I thought you had 33. Okay. Gotcha. Okay, gotcha. And bibliometric data from PubMed, but also the FOIA requests. It'd be great to get later over coffee, what it takes to issue FOIA requests and the speed to get that done, because I think many of us might be interested in issuing those. Again, pretty standard methodology. A difference is a difference in event studies to allow us to think through what's going on. And then, as Ina mentioned, as we reduce, as prices increase, scientists reduce the use of helium, which results in lower number of papers produced. And then there's some clever thoughts here about potentially insurance mechanisms or some other ways to potentially deal with this with these price shocks. So what do I like about this data, about this paper? First is, of course, the data used and getting to the level of the scientists and to the labs, so that we are actually getting into the nitty-gritty of what it takes to get the work done. And I think the use of procurement contracts is a great add-on to the metrics data. I think it's like, again, a very interesting approach. Comprehensive data coverage. So we see a pretty large snapshot, and again, 3,000 labs. Good identification strategy. And you saw from the graph that Ina showed that you see differences in pricing available to the various universities. What's interesting is that the prices are negotiated not at the lab level, but the university level. So the university negotiates the contracts. And there's ample evidence, written evidence about like why a lab may not be able to influence these types of prices. And sensible estimation put into place and policy relevant. So some lingering questions I have. And these are, I would say, sort of on things that are, going to be fixable over time. This is a brand new research stream that Ina has started with Revive, and I think it's very exciting. The construction of the price indices come from aggregated spending data with a vendor, which is a gas supplier, like Air Liquide or Air Gas and so forth. So you don't actually observe the price of helium taken. 5 minutes, great, thanks. And so this could cause some measurement error. The mixture of gases used are actually quite vast, even though helium may be the highest one, but is there some other data on, is the shock of helium also impacting nitrogen or not? Like, do the prices move collectively or not inside of a lab? Labs use more than just helium. I think the setting of nuclear medicine, not nuclear medicine, but MRI systems where the helium is used for cooling is a clear place for this. But labs will be using tons of different gases, and it'd be just good to know if these prices are independent. And then, of course, this question about substitutes, right? Liquid nitrogen can be used for cooling. Not to, what we've seen is with MRIs, and in my prior life, before I became an academic, I was working at GE in the healthcare business, and so we sold MRIs and so forth. And so you could start cooling by liquid nitrogen first, and then at the very last level go to liquid helium if you wanted to. But you can use hydrogen for gas chromatography, argon for shielding. There's many uses of helium throughout the academic scientific complex, and there's a real interesting question about substitutes, and do substitutes show up or not? So as you sort of think about there's a measurement question, but also as you think about your broader study, it's sort of looking at all the types of gases potentially and how they fit in will be fun. So again, I found the explanation of the gas price index construction could be more clearer and maybe less murky. And I guess the question I also had was like, could scientists anticipate shocks? Because it looked like every year there was a shock or something like that in your data. And so depending on the university. And so is there some anticipation of it, and does that actually even build in some degree of how they're thinking through that? Maybe you don't anticipate the first shock, but maybe the second shock or the third shock you might anticipate. And then also there's an interesting thing about force majeure clauses, and I guess those were the ones where there was like a bigger increase in price. I didn't know how that played into your data. I guess it's at the moment it's convenient. It's too focused on life sciences for bibliometric analysis. PubMeds do not cover all of the disciplines where they may be used. Question is, would private universities be any different? So would the large endowments allow you to potentially buffer against it? Do you have reserves available? When we did all the work at Harvard Medical School, there's always slush funds running around, right? That could be that, and so would that mean there's already a built-in insurance buffer inside of private universities? And is this an upper bound or a lower bound? Is a question I had. And I guess it would be great to sort of get a real sense of the economic effect, like how many papers And is it a good thing? Like, sometimes people say there's too many papers being written, right? Maybe the quality, you don't notice the difference in quality, but maybe this is forcing scientists to be more judicious about the papers. Maybe not as many incremental papers are being produced and so forth. I think this text analysis might be very useful that you might go do. And then more explanation on the fact that quantity decreases, but the quality remains the same. Overall, I think this is a great paper. It's well worth your time to follow its development. And I think it's a pretty fantastic research agenda. Thanks.